variables will vary. If you want to make use of those variables, you can even save the variable. So there is a command called as save, S-A-V-E. You can save this variable in the form of mat files. In MATLAB, we got this, the name is like mat and dat, D-A-T is there. Dat is nothing but data file and mat is nothing but MATLAB file, that's all. So that is the abbreviation. You can store in the form of files and keep it in hard disk. So what happens, even if you close the MATLAB, you can use the data without MATLAB also. Okay, once you close the MATLAB, you can even view those images or any other data. Similarly, you can do in the reverse way also. You can load the variables from mat file. And the command is called as load. Same way, you got a function called as clear. Clear actually clears all the workspace. When you type in command window, clear all, clear space all. When you type this command, all the variables in the MATLAB workspace will be cleared. So these commands are usually made use by the researchers when we do some type of iterative processes. When you do like iteration 1 to 100, after first iteration, you may have to clear some of the variables and hold some of the variables. So this clear, specifically you can address a particular variable and clear it. The other variables, if you want to make use of it, don't clear it, that's it. So for iterative programming structures, this clear function will be very useful. So as I told you, you can see the default command window. This is how the screen will appear, where you can type, if your program is less than 10 lines or 20 lines, you can execute in command window itself. You need not go for editor. So these are all the similar screens. At the top, can you see something like current directory? Current directory will be displayed. Where your MATLAB your files are being located. See, what you can do is, the sequence is very simple. First, if you want to write a program, just you have to create a folder anywhere. It is your option. It is your choice. You can choose this you can store it in C drive, D drive, E drive, F drive, anywhere, or in desktop, or a folder within a folder, no problem at all. You can create anywhere and keep it as a folder. I recommend to do anything within a folder. Just create a folder and you type a program and store that file in that particular folder. That's it. Just remember where you have stored. That is very important. Because I'm seeing even especially the learners, the beginners have this problem in handling MATLAB. So that is what I'm making a stress on this. Remember the folder where you keep your files. That folder should be equipped with all the supporting files. This is the thing you have to keep in mind. So whenever you want to open a file, you have to, there is one thing called as file. Can you see on the left hand side? Can you see my mouse pointer? On the left hand side, you see something like file. File is there, file, edit, view, all those things. Okay. If you go to file, if you click it, you will get a string called as open. And you can open it, you browse the folder and you reach the M file and then you can open it and the file will be displayed on the editor window. That's it. Then you can run it, do some modifications, write a new program, whatever it may be. So that is one thing. And now, like other languages, now we are going to slowly get into the syntax and format and other things, whatever, the operators, all those. So the arithmetic operators are displayed in the screen. Like other languages, okay. Here we don't have any changes. Even in C also the same operators are being used. See, after all, it is a mathematics. A plus sign is always a plus sign. It's not going to be changed if it is a different language. Okay. So, but here we have some slight, some technically you have to approach here. Can you see here at the bottom 11 and 12? See, I will tell you like 10, 11, 12. Just see 10, 11, 12. 10 is nothing but a divide operator. A divide operator is nothing but a slash. You could see in your keyboard, there is a slash. Okay, there is a slash, and in the 11th item, you can see dot slash is there, and 12 is nothing but dot slash is there. A backslash is there. See, carefully listen that, watch it. There is a slash and backslash is there. So that are peculiarly used for some applications. If you want to operate element-wise operations, a normal slash is like a divider. Okay, A divided by B. So what you do is A slash B. That's it. But if A is a matrix and B is a matrix, if A consists of 9 elements and B consists of 9 elements, then if you want to do element by element, if you want to divide one element by another element, okay. See, remember, A by B is different, and elements of A divided by elements of B is different. So in such cases, we will be using dot slash. Similarly, asterisk is also there. If you want to multiply, X mark is not used. We will be using asterisk. So in the item 5, you can see matrix multiply is nothing but asterisk. But if you want to do element wise, we call that as array multiply. So there you have to use dot star. Dot asterisk you have to use. So remember, if you want to do element wise, you have to use a dot. Okay. Similarly, the power also. If you want to do some power operations, say 2 power 5. So you have to use this cap symbol in 7 and 8. It's the same way if you want to do element-wise power operation, you have to use that dot preceding that operator. That's it. So just have a look up these arithmetic operators. It's very simple. Just a mathematical operator, just plus, minus, divide and stuff like that. Divide and multiply. That's all. Just 4 things are needed, and making this power operations. So the cap symbol is important. Only these operators you need to remember. Nothing to worry more about this. And we have got some relational operators like equal, not equal. I'm just reading this: equal, not equal, less than, greater than, and less than equal to, and greater than equal to. That's all. These things are already available in any other languages also. Okay, so nothing peculiar in this. This is common into all other languages as well. So the next thing is we have to speak on logical operators. Because see here, what is the purpose of this relation operators? I just want to ask you all. Sometimes I will tell the answer. Okay, no worries, I'll tell the answer. Sometimes you may have to compare the two situations. For example, if this variable is equal to this one. For example, if you want to design a temperature control system using MATLAB, okay, that is highly possible, right? Instrumentation is also possible with image processing. With MATLAB. If you design a temperature control system, what happens if your temperature is exceeding 35 degrees? Then you should switch on an air conditioning system. Okay, say even for a refrigerator, if your temperature is greater than 20 degrees, then you have to switch on the motor. Okay, that is a compressor motor. So when you switch on that, the compressor will run and temperature will come down. So to compare such real-time variables, you definitely need relational operators. We call that as relational operators. If any number is less than the other number or greater than the other number or equal or not equal, any such the relation between the variables, that's it. If you want to do that, you have to use these operators. Similarly, we will now talk about the logical operators. Logical things are there. Sometimes what happens, you all have come across and different types of gates. Okay, we call as logic gates. Those logical operations, especially in fuzzy logic systems. Fuzzy systems are based on several conditions. Okay, if both the inputs are true, what happens? In AND gate, what happens? You very well know. In AND gate, 0, 0 is 0, and 0, 1 is 0, 1, 0 is 0, and 1, 1 is 1. Okay, this is how an AND logic is created. The truth table for AND is created in such a way. Similarly, in MATLAB, we will be able to do all type of logical operations. Okay, there we have some specific command, and even you can do bitwise AND operation is there, bitwise OR operation is there. We have ready-made commands for that. You can use operators also. Suppose if A and B, that means if A is true and if B is true, what happens? So the decision making will be done using this logical operators, and here also in relative operators. And just now I told you something about the bitwise operators. So we have got ready-made functions like a bit AND is there, bit complement is there. Assume if you want to do something, say for example, you have got 8-bit of data. In image processing, a pixel consists of 8 bits. Just remember, any pixel, see, basically how an image is formed. An image is a matrix which consists of pixels. That's all. Say for example, if your image is with a size of 256 by 256. Okay. So then number of rows is 256 and number of columns is 256. So what happens when you multiply these two numbers, 256 multiplied by 256, what you will get is 65,536 you will get. So these are the number of pixels available within a digital image. You got it? Hope you are following me. So out of all these pixels, every pixel will be represented by 8-bit data. Okay, so 8 bits, they are all nothing but an integer. Say the number, starting number will be from 0 up to FF in hexadecimal. So it means that FF is nothing but a decimal equivalent of 255. So the black pixel will be 0 and white pixel will be 1. 1 in the sense 255. The blackest pixel will be like 0, 0, 0, 0, 0, like that. You just make it like 8 bits. All will be 0, and whitest pixel will be like 1, 1, 1, 1, 1, 1. Up to, you have to put like 8 ones, because I already told you 8 bits are required to represent a pixel. Okay, so if you want to do some logical operation between one pixel to other pixel, you can use these commands. Bit AND is there, bit CMP, bit R, bit max, bit XOR. All those are all, see, I'm just to have a read of all these bitwise operators. Instead of I am reading it, you just go through and just keep it in mind. And remember one thing, don't memorize all this. Nothing to worry about this. Just see this and forget it. When you start programming, you do everything with the help of help. Okay, by using the help window, you can do anything. You just don't worry about to remember all this. Just forget it. You will get automatically when you start writing the program. You can, every time your help is always available, by using it, you can do it. So now we'll slowly come into some type of mathematical operations. I'm calling this as a vector. For example, you say A is equal to, there is a square bracket and some numbers are there, and close a square bracket. This is what you can do in a command window. A is equal to, I've given some numbers. So that is a matrix. So remember one thing, MATLAB handles all the data as matrix. So I told you A is equal to 10. In the beginning of the discussions, I told something about A is equal to 10, B is equal to 10, and C is equal to A plus B. So if there is one element, then MATLAB will consider that as a matrix with one row and one column. That's it. So, but here I have declared like A is equal to some square bracket and some numbers. So there are 9 numbers available. That means 9 values are there. So this is called as a row matrix. This consists of one row and 9 elements. Did you get me? A is a variable which consists of 9 elements, and this is an array. We will call it as an array. It is not an individual element. It has got an array. So 9 elements are there, 9 columns are there, and 1 row is there. So it is, the size of this matrix is 1 by 9. That means 1x9. So the size of the matrix is very important to do many of the, not only in image processing, in many other applications, we need to verify the size of the matrix. you know, when you multiply two matrices, the size should be, we should have a 3 cross 3 matrix can't be multiplied with 2 by 2. Am I correct? Hope you all remember the basic mathematical operations. A 3 cross 3 matrix cannot be multiplied with 2 cross 2, right? So likewise, in many times, we will have to verify the size of the matrix. Sometimes you will be getting an error. When you write a program, it will say that the dimension should agree. You will be getting an error message. That is another peculiar strength of the MATLAB. Whenever you do some syntax mistakes in syntax, and whenever your variables do not match, okay, when you do some addition of array, then the size of the array should be same. You can't add a 9-element matrix with a 10-element matrix. That's what I want to say. The dimensions of the variables should agree. That's what I want to say. So 9-element matrix should be added with 9-element another matrix. So the length of the variable should be same. So here what happens is I declared a variable a, and in b is equal to a plus 2. So what happens here? The resultant is, you can see that with all the elements, the number 2 is added. Can you just see it? Please see that variable. What happens to the a? In case of b, all the values are increased with 2. So 1 has become 3 and 2 has become 4. Likewise, the variables are altered. And similarly, we do perform some mathematical operations. C is equal to a plus b. So this is how the arrays are being handled. And since MATLAB itself has got, it deals the data as matrix, it has got peculiar functions to handle matrices. So defining a matrix will be like this. So I have given like P is equal to, if you have to open a square bracket. Whenever you deal with more than 1, if your variable has got numbers more than 1, you have to open a square bracket. Please always remember the variable declaration should be in case of square bracket. And you can see that every row is being separated by a semicolon. Okay, this is how a matrix is represented. Actual matrix is given at the bottom. B is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is the matrix you want to actually represent in MATLAB. So in MATLAB, the syntax is given in the first line where B is equal to square bracket, and every row, the rows are separated with the help of semicolon. That's it. So whenever you put a semicolon, it means that the particular row is ended up. Then other numbers are coming under the next row. So the rows are being separated with semicolon. That's it. Then you can even transpose the matrix. Transpose of matrix. Just if we interchange the rows and columns, then that is called as a transpose matrix. So here it is very simple. B dash, we call it as a dash. C is equal to B dash. So the dash symbol says that it is a transpose of. So transpose of B is stored in C. Now you can compare the B matrix and C matrix. Can you see that rows and columns are interchanged? Please have a look of this. Just compare the matrix B and matrix C. You can see that rows and columns are interchanged. Did you see it? Okay, hope you have seen it. So this is how the transpose operations are done. And some other basic matrix operations are there. You can do inverse matrix. You can calculate the eigenvalues of a matrix, polynomial of a matrix, absolute value of the matrix, minimum value of the matrix, maximum value of the matrix. For all these things, we have ready-made commands. That is what I have been telling from the beginning. The strength of the MATLAB is vast, enormous. For all these things, if you want to do it in C and C++, you may have to write a code of 10 lines or 20 lines. If you want to find out the inverse matrix, you have a peculiar formula. Just you have to apply the formula and write everything in a C code and get the inverse of the matrix. You will require 10 lines and 20 lines and of course 30 minutes of time to find the inverse of a matrix, to design a program. Of course, a computer will do this process within 5 seconds or 2 seconds. but writing the program consumes time. But fortunately, in MATLAB, you can see that there is a ready-made command, just I and V is there. X is equal to inverse of E, that's it. So it is as simple as you do our school level mathematics operations. So this is the peculiarity in MATLAB. And even you can do some convolution operations. So we have a function called as a CO and V. Suppose you have a value X and another value Y. You want to convolute these two variables. Convolution is being used in wireless communications especially, and even in image processing also. We do some operations of convolutions in case of fusion algorithms. So we have got a ready-made function called as a CONV. And even you can do deconvolution as well. And now let us come to how this data is being handled and how we'll be able to plot some figures. Here, this is a plot command. This is an introduction how the data is being plotted. This slide shows you a code of 3 lines, very simple, that plots a sine wave. Okay, it's very simple. First, you have to declare the variable t. T is equal to 0 colon 0.25 colon 7. So this is the total time I'm just declaring it. So before I plot the wave, I'm just declaring the time. It starts with 0. The first number says that the starting element is 0 and ending element is 7. Can you just observe the waveform in the x-axis? Can you see the starting number is 0 and ending number is 7? Yes, hope you're able to see in x-axis. And that 0.25 is nothing but the time step. Time step is nothing but how this time is incremented. So first time t is equal to 0 and next t is equal to 0.25 and next time t is equal to 0.5. That means you have to increment the time in steps of 0.25. That's it. And it goes up to 7 and it ends up at 7. That's all. So now we will have to see y is equal to sine of t. So sine is a command. It's a library command already available. So sine of t will give you the sine values. You know how to calculate the sine values. You don't need to do with pen and paper. MATLAB will take care of it. And the next thing is, after you found out the sine values, use the plot command. Plot of t comma y. It is very simple that t is nothing but your x-axis and y is nothing but your y-axis. That's it. So the plot command will directly give you the sine wave. Suppose you want to, I'll ask you a question. If you want to increase the number of cycles, in this waveform, you've got only one sine wave. Am I correct? Did you notice it? You got only one cycle. Only one cycle is shown. If you want to have one more cycle, what you will have to do in this code? Shall I repeat the question? I am displaying only one sine wave here. If I want to have something as a second cycle, what should I do in this program? It's very simple. I'll tell the answer. In the first variable, t is equal to 0 and colon 0.25 colon, instead of 7, you make it as 14. That's all. So what happens if your time is expanded? If it is expanded, then you will get one more cycle also. So this is how we operate the plot commands. And even you can see here, we have a lot of other facilities offered by MATLAB. Can you just compare these two windows? Can you see any difference between these two windows? This window doesn't consist of a title and doesn't consist what is there in x-axis and what is there in y-axis. But you can see here, x-axis is mentioned, y-axis is mentioned, and heading is also there. And even the graph consists of some type of grids. We call that as a grid. So the function it's a straightforward function given by MATLAB, where you can see x label is there, y label is there. Whatever you want to display in x and y axis, we can use this command x label. So that you will be getting within single quote. Whatever you want to display, you have to use that with single quote, and that will appear on the figure window. So we call this window as a figure window. And grid on is there. Grid on is nothing but you will get some square mesh. You can your display will be perfect. Okay, it looks good when you switch on the grid. You can locate the sample points very closely. You can watch how these points are being varied. So likewise, you can create your user-friendly figure windows. We call these as figure windows. Once you use the command plot, PLOT, you will be getting automatically some figure windows will be opened by MATLAB, and you can assign all this X label, Y label, heading, and everything. So this is the peculiarity in plot commands. And now let us come to some special, commonly available, not special, but these are all the keywords. Okay, we have to talk something about the keywords. If the loops are there, because sometimes we will be checking various conditions. Okay, if this variable is greater than this variable, if A is greater than B, or if A is greater than 6, or A is greater than 10, anything, we want to compare it, for which we will have to use if loop. We call this if-else conditions. You have come across, if you are very good in C, or at least if you have come across C, these functions are very easy to understand. Almost syntax is something similar to C only. If anyone knows C, then he or she will find MATLAB is something closely associated with C language. Here also same thing. Just I'm declaring, if you can see this slide, I'm just declaring first A is equal to 6. And what happens? I'm just checking a condition. If A is greater than 6, just a simple condition, if A is greater than 6. So tell me if this condition is true or not. First line, I declared A is equal to 6. So it is A is equal to 6, that's all. I'm checking if A is greater than 6. No, it is not greater. It is actually equal to 6. It is not greater than 6. So I will have to display a command, like display a statement like A is greater. Otherwise, if A is equal to 0, I'm checking another condition. So the syntax is else if. So if you use any such keywords, an if command will by default end up with end command. So can you just see my mouse pointer? Here I'm starting with if. Please follow my mouse pointer. Here it is if, and this if is actually ended with this final end command. So within that, you can have else if, you can have else. You can keep that within this if and end. So any such keyword will have its associative end command also. Just remember, if you fail to type this end, whenever you are writing a program, if you miss to type end, what happens is, don't worry, MATLAB will indicate that you have done a mistake. It will indicate. While you are doing the programming in editor window, you can see some type of red colored underlines will be given to you. So with that, you can understand that something is wrong in the programming. Okay. So this is how MATLAB helps us. And similarly, you can do some for loop operations. Suppose you want to do some additions for 500 times, 100 times, 1000 times. You can use a for loop. So please remember, just watch here. The for command or the keyword, for keyword is also ending with end. So I'll tell you what happens here. I'm declaring a variable A is equal to 5. Just forget, simply just A is equal to 5. And I'm opening a for loop. For, the syntax is very clearly given. For I is equal to 1 to 5. 1 colon 5. That means it's I will start with 1. Next time I is equal to 2. It goes like 3, 4, 5. So I'm doing this for 5 times. Then within that, what I do is A is equal to A plus 1. So it is very simple. Now during the first iteration, what happens? A is equal to A plus 1. So what is A? A is 5. So 5 plus 1, you will get an answer 6. Now the value of A is modified as 6. Next time, what happens? I is equal to 2. So you do this operation for second time. Now the recent result is 6. 6 plus 1. Now it is updated. So the number is being updated 5 times. And finally, whatever the answer you will be getting at the final step, it will come out of the for loop automatically. Once the number I reaches 5, it comes out of the loop. That's all. After it comes out of the loop, the final value A will be equal to 10. Because 5 is added with 1 5 times, so the final result is 10, and the answer you will be seeing in command window is 10. Is it okay? So this is how the for loop is being used. Hope some of you are good in C, I believe. There you will be able to use a statement called as goto. Have you heard of this statement goto? G-O-T-O. That is the peculiarity in C language. You can jump the execution from anywhere to anywhere. See, for example, after 100th line, you can again go to 150th line. From 150, you can jump to 250th line. From 250, you can again come to the second line of the code. That is highly possible in C because of the availability of the statement called as goto statement. But unfortunately, MATLAB doesn't have that goto statement. Please remember, MATLAB doesn't have goto statement. That facility is not available in MATLAB. Why? Because sometimes if you use goto statement recursively, what will happen is maybe it will corrupt the MATLAB. So I think that should be the reason why goto statement is not available. Then you will have a question, sir, what should I do if I want to jump my execution from somewhere to somewhere? Naturally, it will be required in some common programming requirement. Sometimes you may have to jump from one state to other different state. So at that time, you cannot use goto statement because you don't have it. You will have to use a statement called as while. That is what I am showing you now, called as while loop. You will have to use some while command, and similarly, like for if loop and for loop, for while also you have to use a corresponding end. For if you start with while, you should end that skeleton with the end statement. Okay. For all like other loops also, here also for while loop we have to use end statement. So here I am using a command C. The goto statement is actually achieved with the peculiar programming. You can see I am just declaring A is equal to 5. Okay, any number, just A is equal to 5. If A is less than 10, do this operation. If not, you come out of the loop. That's all. So every time I'm incrementing A. So slowly the A will become like 5, 6, 7, 8, 9, 10. Till it is less than 10, the loop will be executed. Once it exceeds, it comes out of the loop. So goto statement can be implemented using while loop also. Okay, so keep it in mind. We don't have goto statement. Only while loop is available. We have to make use of while loop instead of goto in any other language. Okay. So that is one thing. And we have got some functions like this. I already told you there are some arithmetic operators, plus, minus, asterisk, and backslash. These are the arithmetic operators used for addition, subtraction, multiplication, and division. Fortunately, we have some ready-made commands. That means we have to create such functions. We call those functions as user-defined functions. We only create some type of functions. You can name it. You can give your own name, any name. Like I am giving some ADD. In order to perform some addition of A and B, I am creating a function. That function name is called as C. C is equal to add open bracket A comma B and close bracket. So this is the user-defined function which we created. And within that function, you use mathematical operation. C is equal to A plus B and return. So this is an example of user-defined function. Likewise, not only for addition and multiplication, any other, suppose you want to do in a particular operation many times. Say something you want to do iteratively, 1, 2, 3, 5, 10, 100, 500, like that. If you want to do it many times, we cannot write the codes in the main file. So as a common programmer, you might have known this technique already. When you want to do something repeatedly, you write it as a function and call that function. That is very simple. Instead of writing the code every time, if you want to do it 500 times, should you write it 500 times? Not necessary. Okay. So you write the function once and call the function. Okay. This is commonly known as subroutines. Have you heard of this? In other languages, you will call this as a subroutines. The same way here also, we call this as a function calling. Whenever you call this function add of a comma b, then that function will be called. Please remember, these functions are also saved as files. Like what we do in C. Suppose you build a project in C, the file will be like xyz.prj. That is the extension, right? In C language, if you want to build a project, the file name will be xyz.prj. Okay, with an extension of prj. You have to add more number of files within the project. Okay, those files will be with an extension of .c. Similarly, in MATLAB also, your main function will be there. We call that as main.m. You can give any name. Just to remember and just to show that that is the main file, I'm giving the name like main. Okay, main.m will be there. Once you call some functions from this main file, you can give any name. That file also will be stored with an extension of m. And you have to keep that file within the folder itself. That's what I already told you. Whenever you want to do some coding work, create a folder, keep all the files in the same folder. Once you call some functions, that function also that file also should be within the same folder. Please remember, if your main file is in one folder and subroutine is in another folder, it will not work out. Okay, remember, all those files should be put in the same folder. This is the thing you have to remember. So this is all about the user-defined functions. Okay, and switch case statement is also there. Like what we have seen, if loop is there, and conditional statements. If you want to do, if this condition is checked or not, if this is true or not, this is true or false. So all those you will check with if loop. And if you want to do something several times, you will use a for loop. Similarly, if you want to check some condition, you can use while loop. Similarly, you can check some conditions using switch case also. You would have heard about switch case statements. Okay. So here in MATLAB also, we have got switch case statements. You can compare several cases. Any number of cases, you can compare it. And based on that, if any condition is fulfilled, then suddenly you can reroute. We call it as the rerouting. Suddenly you can, if some condition is checked and if the condition is true, then from line number 5, you can directly go to the 50th line, maybe, for example. You can switch the execution from somewhere to somewhere, provided if some condition is satisfied. Okay, if some condition is satisfied, you can switch the execution sequence. So that is the use of switch case statement. See, for example, you see here is a simple program. Simple program by using a switch case statement. First, I will input a letter A is equal to. Input is a function which will get any number from you. Okay. Once you execute this command, you will have to give a number. Say, for example, if you assume that if you type a number like 2, then this variable A will be assigned with 2. So now A is equal to 2. That's all. You have given an input. Now what I'm doing is I am checking the value of A. So the syntax is very simple. Switch space A. So I have to use some cases. Should I go for case 1 or case 2, case 3, case 4, and otherwise is there. That is the default condition. So you remember that you have typed A is equal to 2. Okay. So A is equal to 2 you have typed. Now case 1 will not be applicable because you entered the number 2. Okay. So case 1 is nothing but invalid and case 2 is valid because you have given the number 2, and case 3 is invalid and case 4 is invalid and otherwise is also invalid. So what happens is, in your screen you will get a number, you will get a display like TWO. That's it. You will get a TWO because you entered number 2 and it is falling under case 2. You will be getting a display TOW. Suppose assume if you enter some number 10, a different number 10, and that case is not available in these statements. Case 1 is not there, it is not applicable. Case 2 is also not applicable. 3 and 4 also not applicable. Only the final otherwise is applicable because it is not falling under any of these 4 categories. 1, 2, 3, 4. None of them are valid. So you will get in a screen, you will get a display like otherwise. Fprintf otherwise. So this is how the switch case statements are handled in MATLAB. And remember here also, just watch it. Switch statement is also concluded with the corresponding end statement is there. Okay. So once you start, please remember, if, for, while, and switch. In all these cases, you will have to have a corresponding end statement. If you don't do that, it will show you a syntax error. Is it fine? And we will have to talk about scripts and functions. Instead of scripts and functions, I will deal this problem in a peculiar different way. I just now told you, we have been seeing in all this time. I am just scrolling this presentation from the beginning. Just look into this. We had this command window. I'm just summarizing this. Please follow very carefully. I'm just summarizing this. We started with the command window, and we started with the arithmetic operators, relational operators, logical operators, bitwise operators, vectors, matrices, matrix operations, and even we plotted some data, and we decorated this figure window, and we talked about if loop, for loop, while loop, and several user-defined functions, and we talked about switch case statements, and all these things are called as scripting. We have 2 methods in MATLAB to design and analyze a system. Please remember, we have 2 methods. One method is a scripting method. The other one is modeling method. Please keep this in mind. This is very important. We have 2 methods in MATLAB to design and analyze. One is scripting method. In all this time, for the past 1 hour, we had been discussing on scripting method. Why we call this as a scripting method? Scripting is nothing but you are writing some script, that's all. Am I correct? You open an editor window, you are writing some program. That is nothing but you are writing some script. Okay, that is why we call this as a scripting method. Whereas in modeling method, we use Simulink models. Have you heard of this term Simulink model? Okay, I will tell you. Simulink modeling, that is nothing but MATLAB is providing you the easiest way of doing programming. Just to do some drag and drop operations, that's all. Suppose you want to do Fourier transform. Say for example, I give you a variable x. X is equal to some numbers, okay. X is equal to some 2, 3, 4, something like that. X is given to you. And I'm asking you to apply Fourier transform for that number. Okay, what will it do? We have a ready-made function called as FFT. So what you will do is y is equal to FFT of x. Okay, y is equal to FFT of x. That's all. That is the ready-made command available in MATLAB. Job is over. But sometimes what happens, suppose if you don't know the command FFT. Okay, there is chance. A programmer may not know. Sometimes, okay, sir, I don't know what is the name of the function for taking FFT. Don't worry. Just come to Simulink model. You have a ready-made library box. It is like a box. In Simulink, I'll show you in the afternoon session. I'll show you how to do this modeling. how to do Simulink modeling, where you have got FFT box will be there. Just it will be available in library. Just take it, drag it, and drop it in a window. That's all. Then you give an input X to that. Output will be the Fourier transform of X. That's all. So what you understand now is you can do any operation in two methods. One is scripting and the other one is modeling. That's all. So of course, today we are not going to see anything in the Simulink modeling. Okay, that is beyond the scope of our discussion today. So we will be, working only with the scripting method. Of course, remember, for most of the image processing applications, scripting is enough. No need to go for modeling methods. Maybe for power electronics and drives and power system applications and automobile applications, even embedded systems. For all those, you may need modeling methods, Simulink modeling methods. But for image processing, in my experience, I feel comfortable with scripting. And also, most of the programmers are using a scripting method only. Okay, we will find it easy when we work with the scripting methods. So remember, all the scripts are stored with an extension of M. We call it as M file. That's it. In MATLAB, in C, we call as C file. MATLAB, we call as M file. That's it. As simple as seen in other languages. So we will have the file with M. We call all those as M files. It is followed worldwide. You should be remembering this. Okay, this is very particularly I'm telling. The images are available in various formats. Not all the images are available in the common format. Several formats are being used by several authorities. For example, if it is a medical image, you cannot expect a medical image in a normal JPG format or a BMP format. We have a format called as DICOM, DICOM. It is called as DICOM format. And some other files are available in RAS format, RAS. So the file name with an extension. Okay, just like the MATLAB file, we have got an extension of M. Image files have got an extension of BMP, JPG, PNG, GIF, TIFF, TIF, and TIFF, and RAS format and DICOM format. Several formats are there. So you have to be very particular on what format it is. Most of the formats are being supported by MATLAB, but unfortunately, some of the files could not be readable by MATLAB. In such cases, you have to write some separate functions for that to read some peculiar file extensions. Okay, so remember, mostly 90% of the image formats are readable by MATLAB. In case some 10% of the file formats are not readable, if some commands are not available in MATLAB, you may have to write a separate function for that. So here, I'm just reading an image with the TIFF. TIF is nothing but tagged information format. TIFS, okay. TIFF is nothing but tagged information file format. So don't worry about these extensions. If you are able to go to Google and find it out, it will be very easy. Okay. Whenever you have any doubt, just Google and find it out. It will be easy. And this function is nothing but I'm just assigning a variable. A is equal to, just see the first line on the left hand side. A is equal to imRead cameraman.tiff. Just see, this is the syntax to read the image. imRead, that is the function. That is the built-in function available in MATLAB, where the file name is cameraman.tiff. So the full file name you have to give. So you can see on the left hand side and the right hand side, you have a single quote is there. Could you see it? A single quote is there. The file name is enclosed with the single quotes on both the sides. So that means that your image file is available in the same folder. Suppose you will ask a question, sir, if my image is in a different folder, how should I read it? The question is valid question. Okay. Suppose you want to read an image which is you are writing a program in C drive. Assume you are writing a program in C drive, but you want to access the image which is in F drive. Okay, there are chances, right? Your F drive will consist of images. So in that case, you have to give the full path. We call it as a path. Path is nothing but where that particular folder is located. C drive /desktop /Vijayan some name of the folder. So you have to mention the full file path. Okay, so this you have to be particular. And after reading it, I am displaying it on the screen using a command called as IMShow. The command is very simple, IMShow. That's all, IMShow. What do you want to display? Because I already have a variable A. I already read the image and stored it in a variable A. Just show IMShow, open bracket A and close bracket, that's all. So what happens is, you will get that figure window. You can see there is a cameraman, and please note down that this image is a gray level image. Don't ever call that as a black and white image. If you are a real good image processing engineer, you should call it as a gray level image. Don't always call it as a black and white image. You should always call it as a gray image. And on the right hand side, you can see a color image is there, which consists of flowers. So my file is flowers.tiff. I'm just storing the same in a variable A, and I'm doing it IMShow. Pixel values on. Pixval on is a command where you can visualize the pixel values in the command window. So that is the peculiar use of that function called as pixval. PAXVAL is there. So this is what is being used to read an image and display the image. That's all. This is the simplest operation which I can tell now. Similarly, you can read any other audio file also. See, please understand that we are not concerned with audio files today, but I want to convey how this data is being read in MATLAB. For reading an image, you use a command IMRead. Similarly, if you want to read an audio, we use a command called as waveread. As usual, you will store that variable A is equal to waveread, and you have some file. The test.wave is your audio file, and you can play it. See, once you read the image, you're displaying it. Similarly, once you read the audio, you have to play it. So you should get some audio from that. And plot command is there. Already you know what is a plot command. Plot is nothing but how the data varies. So this plot command, you are able to visualize how that audio signal will be available in real time. You know, just like a wavy nature, you can do that with the help of plot command. And here is the command to read the video. Of course, this is relevant to us. You have to. We have a command like avi read, and the file name is movie.avi. It's very simple. As images are available in different formats, even videos are also available in different formats. Hope you are already known with video formats like MPEG files are there, and AVI files are there. Am I correct? So there are several extensions of video files. Here also, like in the previous case, you have to mention the full file name along with the format also, in what format the video is available. Okay. And you have to read that and store it in the variable A. In the same way, if you use the command movie, there is a command, okay, MOVIE. This is a built-in command. Once you put the variable, what variable you want to visualize, because already I have stored that in the variable A. That's it. Then you have to play that variable. Then automatically in MATLAB window, you will be able to see a video will be playing. So this is how we do read the images and the video files. But I just want to say, again, I will come back to this IMRead. If you want to do this in C or C++, you will have to write your own for loop. Please remember, there are no ready-made commands available in C to read the image directly. You will have to write a 5 to 10 line, definitely more than 10 lines of code is required, where you have to open a for loop within a for loop. Hope you remember how to read a matrix. I already told you, image is nothing but a group of pixels which is represented by a matrix, because it is a two-dimensional data. Am I correct? An image is a two-dimensional data which consists of number of rows and number of columns. So you can see that as a matrix. You can consider that as a matrix. So to read a matrix, hope you all know that in your earlier semesters you would have studied how to read a matrix. You have to use a for loop within a for loop. So likewise, you have to read pixel by pixel. Take one pixel. Say, suppose if your image is f of x comma y, then first you have to read f of 1 comma 1, then 1 comma 2, 1 comma 3. Likewise, if you go to up to the final number, say 1 comma 256. After completing this, next you have to come to the next row. Then you have to read f of 2 comma 1, 2 comma 2, 2 comma 3, likewise. So you have to do for loop within a for loop. So that is a tedious process. But see, what happens in MATLAB, just one line of command, that's all, one line, one word, it's sufficient. A is equal to I am read. Job is over. Simple. So that is why I am telling you, MATLAB will save enormous time of researchers. Just take the function, use it and finish the job. Simple. You don't need to break your head with complex coding works. That is why we call MATLAB is peculiar and especially meant for research applications. Okay. So now let us come out of this, and this is how we will read the video file. And here you can see for all these things we are going to try in the afternoon session. And can you see I'm combining these two images on the left hand side. There is a rice image is available and cameraman image is available. You see how I am just clubbing it. Just I am combining two images. Please remember here, as I already told you, the size of the two images should be same. You cannot add an image of 256 by 256 with an image of 512 by 512. So I already told you, once you want to do some mathematical operations, the array should be same. I mean, the size of the arrays should be same. Otherwise, you cannot do these mathematical operations, and you will be getting an error also. Once you try to, suppose you will ask me, sir, what happens if I try to add arrays of two different sizes? Nothing will happen. You will get an error message in the command window, that's all. So then here you can see, I am reading two images. Rice image is there and the cameraman image is there. That is stored in the variable I is equal to j. I and j. And k is nothing but, I'm using one command called as imadd. See here only you have to really wonder on MATLAB. If I want to add two images in other languages, I have to add pixel by pixel. First pixel of the first image is added with the first pixel of the second image. Do it for next 2 with 2, 3 with 3, 4 with 4. Likewise, again you have to write a for loop and add all the corresponding elements. If you do it, you will get this resultant image. But fortunately, you see there is a ready-made command in MATLAB called as imadd. So just you have to input the two variables I comma j. So if you add it, you will get a resultant variable k. If you want to display it, use imshow command. Imshow of open bracket k and close bracket. That's it. So you can see the combination of these two images. And one more thing, on the right hand side, you can see two images are there, rice images are there. Can you see any difference between these two rice images? I'll ask you, anyone, can you answer me? What is the difference between these two rice images? Can you visually see the difference? The first rice image is somewhat black in appearance, and the second rice image is somewhat brighter. Can you see that? So it means that you are increasing the brightness of the image. That's all. So how it is done? This is something like image enhancement. There are a lot of applications in image processing. Okay. One application is called as image enhancement. Enhancement is nothing but something is not good, I want to improve it. That is nothing but enhancement. Okay. On the left hand side, you see that images are somewhat black in appearance. That means contrast is more. Contrast is more. So I want to reduce the contrast and increase the brightness. So can you see that the second image is brighter than the first image? Hope you are able to see that. Similarly, how we are doing it? Okay, we have to discuss on that. So I is equal to, I will start with the coding. Just 4 lines of codes. Just remember, just 4 lines of codes. I'm reading I is equal to im read. That is the command, which already you know how to read the image, right? Im read. Within the bracket, you give the input argument. Input argument is nothing but your file name. That's all. Your file is rise.tif. Just read it and store it in the variable I. That's all. After storing it, you add a number 50. I am using again a command called as imadd. So imadd is a ready-made command where you will be adding the variable I with 50. I is nothing but, already you know that I is nothing but your image, which consists of values of all the pixels. So for every element, you will be adding a number 50. What happens is, it means that you are adding a number 50. It means that you are increasing the amount of white in the image. That means more white is added to every pixel. So how much is that more? 50 is the more. What happens in the place of 50 if I make as 100? It is your choice. You add any number, nothing happens. Your laptop or computer doesn't bust out. Suppose you commit some mistakes, nothing happens. Don't worry, your laptop is not going to explode. Simply try something. When you do coding, instead of 50, if you make 100, what happens is the image brightness will still increase. Suppose I will ask you, what happens if I want to increase the contrast? So instead of imadd, I will be using im subtract. That's all. Just reduce the value of white, then the contrast will be increased. If you add a number, the brightness is increased. If you subtract a number, the contrast is increased. Okay, remember in that way. So this is how we do spatial operations. Whatever we have discussed now, they are called as spatial operations. Why we call as spatial operations? Excuse me. Hello. Yes, madam. Yeah, just few minutes. Yes, madam. Just few minutes. I'll conclude this session. Yeah. Yes, madam. Yeah. Thank you. Excuse me. So what we have now is we discussed all the spatial domain operations. Why we call as a spatial domain is you directly go to the pixel and change the values of the pixel. We are doing this in a spatial domain. So we call these operations as spatial domain operations. Okay. So in the afternoon session, I think it's almost time. In the afternoon session, we will discuss with some of the spatial domain operations and even frequency domain operations as well. So that what you have to do is just observe my screen and I'll be typing the commands and executing the program and showing what happens with some commands. If I write a program, what is the purpose of program and what is the output of the program? Just you need to follow me carefully and observe my screen. That's enough. So you need not have MATLAB with you because already I have got 2021. Just follow the screen. That's enough. So thank you very much for your patience, my dear student friends. I appreciate your patience and following me and hope you listen me carefully so that it will help in the afternoon session. Okay. Thank you one and all. And again, we'll be meeting in the afternoon session by 2 o'clock. Thank you, Professor Mohan Sundari and Professor Jenny Bharati. Yeah, we'll be meeting again by 2 o'clock. Thank you again.
Thank you, sir. Thank you all. Please, we'll resume the session by 2 p.m. sharply. We'll have lunch and come back. Thank you. Anusha.